Lagrange interpolation. So, what is Lagrange interpolation? Lagrange interpolation is a mathematical technique used to approximate a function within a certain range using a polynomial that passes through a given set of data points. It is named after the Italian-French mathematician Joseph Louis Lagrange. This interpolation method is particularly useful when you have a discrete set of data points and want to estimate values between those data points. It allows you to create a smooth polynomial representation of a function based on limited data, making it useful in various fields such as physics, engineering, computer graphics, and more.
I will explain three types of interpolation: linear, polynomial, and spline interpolation. Each method helps us estimate values within a range of data points. First, we have linear interpolation. This method connects two data points with a straight line. It is very simple and easy to use, but it may not be accurate if the data is not linear or follows a curve. Next is polynomial interpolation. In this method, we use polynomials to create a smooth curve that passes through multiple data points. It is useful when we need precise fit for small datasets. Lagrange interpolation is one specific type of polynomial interpolation. Finally, we have spline interpolation. Instead of using one large polynomial, it divides the data into smaller sections and applies different polynomials to each. This makes it better for large datasets and provides smoother results.
Why did we use Lagrange interpolation? Lagrange interpolation is particularly useful because it provides a straightforward way to interpolate data without needing to solve a system of equations, which makes it easy to understand and apply. This is especially valuable when we have a set of data points and want to estimate values between them. Now, let's look at the Lagrange interpolation formula. This formula helps us to find a polynomial that passes through a set of points. In this formula, fx represents the value we want to find. The terms in parentheses like x minus x naught show how far x is from each known point, x naught, x1 until xn. Each term is multiplied together, and when we combine all the points, we get a polynomial that fits through them. So we use the input values and their corresponding outputs to create a new polynomial that estimates values in between. For example, if we know values for x0, x1, and x2, we can use them to create a polynomial that estimates values between those points.
Hello, my name is Ryan and I'm going to teach you how to do this question. So, x minus 4, x minus 5, x minus 6, 1 minus 4, 1 minus 5, 1 minus 6, multiplied by dy to 0.0248. So, the first part here, we are looking for this point here. So this is the x, this is the y. The point that we are looking for is number 1. X is equal to 2. So this upper side, all you gotta do is x minus by all of this, except number 1. While on the lower side, you gotta minus all of it except number 1. So 1 minus 4, 1 minus 5, 1 minus 6. And you have to do it. You have to do it for all of the points. So I'm going to show you again. So now we are looking for number 4. So the first part is 2 minus 1. We're not going to minus 4 because that is the one we are looking for. So 2 minus 6. And then 4 minus 1, 4 minus 5, 4 minus 6, and obviously we are not going to minus 4 because that is the one that we are looking for. And then we're going to multiply the y, which is 8.1915, and that's it. I'm going to show you when everything is over. Okay, so this is 4 number 1, and this is 4 number 4. This is 4 number 5, and this is 4 number 6. So you calculate all of this and get this, and get the answer, and then you're going to gather all of it in one, and you plus it all. So here we got plus minus, which is equal to minus, which is, when calculated, the final answer will be 4.6379. So yeah, that's it. That is your Lagrange interpolation. Not that hard.
Okay, so for the last one is conclusion. Lagrange interpolation is a way to find a smooth polynomial that's passed through a set of given points. This works well for small numbers of points given an exact fit. However, if you use it with too many points, the curve can behave strangely and become less reliable. For a larger dataset, and the method like spline are usually better.